Let's start with something we're all familiar with, stuff. For the sake of sounding smart, we'll refer to stuff as matter. Now, matter has been the object of scientific study since science was first invented. It's only natural for us to be curious about the things we interact with and what they're made of. So let's talk about a famous experiment that tells us about the nature of matter, the double slit experiment. Let's say we have a gun that shoots out tiny marbles at a screen. They will be our particles of stuff for this experiment. In this screen is a tiny slit. Any of the marbles that hit the screen bounce off, but those that do go through the slit continue on to become embedded in a wall behind the screen. They form a pattern that looks like the slit they came through. Simple enough. If we make two slits, we would likewise get two lines of marbles along the back wall. This is exactly how we expect matter to work. Now, let's take that same setup, but submerge it in a pool. Instead of shooting marbles at the screen, we'll send waves through the water at the screen. When the waves pass through the two slits, they create two new sets of waves. These waves interact with each other to create constructive and destructive interference. I'll spare you all the math, but the end result is that the pattern on the back wall is a series of lines showing all the locations where these waves interfere. As such, it is known as an interference pattern. Up until now, things have been pretty straightforward. Our matter is acting like stuff we expect it to. But what happens when we shrink things down? Instead of waves of water, we can use waves of light aimed at the two slits. We once again get the interference pattern we would expect from waves. So far, so good. Now, let's try using particles again. On this scale, we can't use marbles. Instead, we shoot electrons. Electrons, part of what makes up every atom, are the tiny particles of stuff for this part of the experiment. So we shoot them through the two slits and look to find our two lines like we did with the marbles. This is where things start to get weird. If we do this kind of experiment, what shows up is an interference pattern. Now, when this first occurred, many physicists were bewildered. They thought that perhaps the electrons being shot were simply bouncing off of each other after going through the slits, and that's what caused the interference pattern. So they ran the experiment again, but this time they shot single electrons at a time. After waiting a long time to allow for buildup, they checked the results and found an interference pattern. So single electrons, particles of stuff, were flying through the screen by themselves and then creating an interference pattern. So the big question was, what are they interfering with? Here's the shocker. Each electron went through both slits and then interfered with itself. As it turns out, matter is fundamentally made up of waves. Each electron can therefore go through either slit, both slits, and neither slit all at the same time. Now, that's actually an interesting concept in physics, all at the same time, or simultaneity. It isn't as straightforward as you might think. Let's work through one of Einstein's famous thought experiments. You are riding on a train. I am a broke college student, and so I can't afford a ticket. I'm standing out beside the train. Now, this isn't any ordinary train. This train travels at near the speed of light. If you, or someone you know is an engineer, you might hear, but there's no way to feasibly get a train up to the near light speed. Yes, I know this, but shut up. There's a reason it's a thought experiment. Anyway, you're traveling superbly fast, and I am just standing still. Now, to set the mood a little bit more dramatically, let's say you're traveling through a dark and windy thunderstorm. Suddenly, lightning comes down from the sky and strikes the front of your train car and the back of your train car. Now me, standing out in the rain, miserable and cold, observe the lightning strike of the two ends of the car at the same time. If they're in the back of the distance from me, I can then deduce that they happened at the same time. I might guess that from your comfy, warm seat in the center of the train,
things might look different. Because you are traveling at near the speed of light, you effectively run into the light from the lightning in front, while the light from the lightning in back has to catch up to you. So you observe the light at different times, and therefore deduce that the lightning occurred at different times. So who is correct? Both of us. Lightning struck simultaneously and at different times, based solely on our different frames of reference. Now maybe this all makes perfect sense to you. If that's the case, I invite you to get a degree in physics because you have talent. These ideas shake, to me, the very core of existence itself. In my opinion, these ideas are a little bit scary.
The whens and whats and hows we think are all wrong, but they're also all right, and who knows what is where or when, and it goes on and on. Reality isn't as straightforward as we'd like it all to be. So what's the result? Well, so far nothing. Both of the experiments I've described are almost a century old. Life continues to go on as it always has. Most of us don't have experiences at near light speed, or at subatomic sizes, and as such, these things aren't directly important to us. But just because they don't mean anything in the way we operate now, doesn't mean they won't someday become important. I might remind you that in the 1500s, the idea of the Earth orbiting the Sun was hard for many to grasp, and frankly, a little scary. It took 400 plus years to take the basic understanding of how our solar system is structured to the point where mankind actually got off this big rock and into outer space. So just keep that in mind. Science is weird. Science is scary. But science is also always discovering more about our world, about our universe, and about our reality. Or should I say, realities. And it only takes a little bit of time to take that science and use it for something beautiful.